Hey everyone, and welcome back to the channel. Today, we're embarking on an incredible journey back in time, deep into our own origin story. For centuries, we've pieced together the puzzle of human evolution using fossilized bones and ancient tools. But what if I told you there's a hidden code? A biological manuscript preserved for millennia that's completely rewriting what we thought we knew. This isn't science fiction. It's the reality of ancient DNA. Imagine holding a fragment of bone from an ancestor who lived 50,000 years ago. For the longest time, its shape and size were all we had. We could guess how they lived, what they looked like, but the full picture remained a mystery. Now, scientists can extract microscopic fragments of DNA from that same bone. It's like finding the original instruction manual for a long-lost relative. This genetic revolution has turned a few dusty fossils into a vibrant, interconnected family tree. And the story it tells is far more complex and fascinating than we ever imagined. Let's start with a group you've probably heard of, the Neanderthals. For a long time, they were painted as our brutish, less intelligent cousins who simply vanished when modern humans arrived. The classic story was one of replacement. We sewed up, and they died out. But ancient DNA tells a different tale. By sequencing the Neanderthal genome, scientists made a startling discovery. If your ancestry is from outside of Africa, you likely carry between 1 to 4% Neanderthal DNA in your own genetic code. Think about that. They didn't just disappear, they assimilated. Our ancestors met, interacted, and had children together. This wasn't a simple replacement. It was a merger. It means that a small part of the Neanderthals lives on in billions of us today, influencing everything from our immune systems to our skin's response to sunlight. But the story gets even stranger. As scientists started analyzing more ancient remains, they stumbled upon a finger bone and a few teeth in a cave in Siberia called Denisovans. They didn't look particularly special, but when the DNA was extracted, it didn't match modern humans or Neanderthals. It was something entirely new. They called them the Denisovans. This was a ghost population, a group of ancient humans we knew almost nothing about from the fossil record, but whose genetic footprint was undeniable. We now know that Denisovans also interbred with our ancestors, especially in populations across Southeast Asia and Oceania. Some people in Papua New Guinea, for example, carry up to 6% Denisovan DNA. We had discovered a whole new branch of the human family, not from a complete skeleton, but from the genetic code left behind in a tiny piece of bone. So our family tree isn't a straight line leading to us. It's a messy, tangled web. Picture this. For tens of thousands of years, the world was home to multiple types of humans. There were modern humans, Neanderthals, Denisovans, and likely others we haven't even discovered yet. And they weren't living in total isolation. They were meeting, trading, and, yes, interbreeding. It was a world far more diverse than our own today. This completely changes our perspective. Instead of seeing ourselves as the single, inevitable pinnacle of evolution, we are the last survivors of a once diverse human family, carrying the genetic echoes of our lost relatives within us. This ancient DNA isn't just rewriting our deep past. It's also solving more recent mysteries. Take the peopling of the Americas. The traditional view was that a single wave of people crossed the Bering Land Bridge around 13,000 years ago. But by analyzing DNA from ancient skeletons found across North and South America, a more complex picture has emerged. Genetic evidence points to multiple waves of migration, different founding groups, and a much faster expansion across the continents than previously thought. We can even trace the genetic lineages of specific populations back to their Siberian ancestors, mapping out a migration story that was once pure speculation. And what about Europe? The DNA from ancient European farmers, hunters, and pastoralists has revealed a story of massive, continent-shaking migrations. It turns out that modern Europeans are a genetic blend of at least 3 major ancient populations. First came the original hunt. Then, around 7,000 years ago, a wave of early farmers migrated from Anatolia, now modern-day Turkey, bringing agriculture with them. Finally, a later migration from the Eurasian steppe, the Amnaya people, swept across Europe about 5,000 years ago, bringing new technologies, languages, and, of course, their DNA. Each of these events left an indelible mark on the European gene pool. This isn't just a story of cultural change, it's a story of people physically moving and mixing on a grand scale. The power of this technology is simply mind-boggling. We're now able to extract DNA, not just from bones, but from the dirt on a cave floor, from ancient pottery, and even from the chewing gum of our ancestors. Lumps of birch pitch they chewed on. This sedimentary DNA allows us to see who was in a specific place at a specific time, even if they left no bones behind. We can reconstruct entire ecosystems and identify the presence of different human groups and the animals they hunted, all from a pinch of ancient dust. This is like a genetic time machine, allowing us to witness snapshots of prehistoric life that were previously invisible. So, what does this all mean for us? Right now, it shows us that our history is one of connection, migration, and mixing. The idea of distinct, pure ancestral groups that existed in isolation is a modern fiction. Our strength and resilience as a species have come from our diversity and our ability to adapt and intermingle. The DNA within you is a living library of human history, a testament to the incredible journeys, struggles, and connections of countless ancestors, including those who were not modern humans. It's a powerful reminder that we are all, quite literally, one big, complicated, and deeply interconnected family. The origin code in our bones reveals a past far richer and more intricate than we ever dared to dream. Thanks so much for joining me on this deep dive into our genetic past. If you found this as fascinating as I do, please hit that like button and subscribe for more journeys into science and history. Let me know in the comments what part of this story blew your mind the most. Until next time, stay curious.